Yeah, good evening. See, last topic, new features. Last topic. So, multi-threading, synchronization is all completed. So only one topic, last topic, new features. Like version wise, I'll give first version, 3 columns, write it. Version, year, new features. Version, year, new features. 3 columns, write it. Version, year, new features. Version, year, new features. See, JDK 1.0. Java Development Kit. Java Development Kit 1.0. It is introduced in 1995 December, 1996 January. So 95 released. This is Java class. Java class. To Python beside room. This is Java class. Java, that to last topic. This is Java class. Any Python students are there beside room? See. See JDK 1.0. Java Development Kit 1.0. So first version introduced in 1995. New features 1995. Total Java is new. Total Java is new. New feature comes in next version. Okay. So it is starting language. Initial language. Initial language. JDK 1.0 introduced in 1995. That is initial language. Starting language. Starting language. Later JDK 1.1 came. JDK 1.1 1997. After 2 years introduced. Here one new feature introduced, inner classes. So initially inner classes was not there. Previously inner classes were not there. Later introduced. JDK 1.1 1997. Inner classes. Inner classes you studied. How many types of inner classes? How many? 4. What are those? Member class, static member class, local class, anonymous class. Anonymous class also one type of local class. Okay. Inner classes already I taught. JDK 1.2 1998. One new feature introduced, strict FP keyword. Strict FP keyword. Strict FP keyword. See 1995 language is new. It is starting language. Okay. 1995 total Java is new. 1997 one feature introduced, inner classes. 1998 in one more version, strict FP keyword introduced. I didn't teach that one. I have to teach. Okay. Say version to version, many new features will be there. Only important features you are learning. That too, these features are divided into 3 categories: language features, library features, JVM features. So JVM changes also, new concepts will be there, internal, and language changes also will be there. Library changes also will be there. What you are going to learn is language changes only you are going to learn. Library changes version to version, thousands of classes introducing, thousands of classes, that is no need to learn. Internal changes, software changes, JVM changes, no need to learn. Only language changes you are going to learn. See, if you open here Java version history, if you open, if you type, first site only Wikipedia site appears. If you click here, it shows. See, see, you observe JDK beta, JDK 1.0, actually alpha, beta, gamma will be there. So alpha nothing but in that company only they'll check it. Beta they'll release in public. Finalized version 1.0 like. So 95 December, 91 6 January at the time came this is. So JDK 1.0. Later it is changed to J2SE 1.2 onwards. So you can call JDK 1.2 or JDK J2SE 1.2 you can call. Later it is changed Java SE. Now here list of features here also available. Say JDK 1.1. The JDK 1.0, the first version of Java, January 23, 1996 released. Okay. Like this 1.0.2, 1.0.2, 1.1.1 like that, so many will be there. Okay. Little bit changes are there, like this comes 1.0.2, 1.0.3, 1.0.4 like that also. Here you observe 1.1. See AWT, inner classes, Java Beans, JDBC, RMI, serialization, see reflection, these all JIT, many are there. But here AWT, it is outdated, no need to learn. Inner classes I given. Java Beans, JDBC comes under advanced Java. RMI serialization comes under advanced Java. This serialization core Java concept only. This is also you can call. It is also a new feature like that you can add if you want. This is serialization concept also introduced here. Serialization. So JDK 1.1 serialization also. Serialization you studied, no? What is serialization? What is serialization? Studied, completed. Forgot. What is serialization? Converting object into series of bits. Converting object into series of bits is called serialization. If you want to send data in network, if you want to send object in network, or if you want to receive from network, if you want to write to a file, if you want to read from file, in that situation serialization required. Okay. Here actually here serialization, this concept also introduced. Okay. See, it is 1 point here. This is, see, it is AWT. It is outdated. No need to learn. It is Java Beans, comes under advanced Java. JDBC comes under advanced Java. But according to Sun Microsystem, there is no core Java, there is no advanced Java. That's what all included here only. Okay. This comes under advanced Java. RMI comes under Java EE. So like this will be there. Reflection, it comes under advanced Java. So these all, it is internal. It is not required to learn these all. So these all not required. Here, strict FP, swing. It is we stop to use learning this swing. These all internals. So only collections framework, library changes. That is already taught everything. That is no need to write separate. So strict FP keyword introduced 1.2 version. 1.3, there is no changes in the language. No changes. Other changes are there. 1.4, one changes are there. Assertions. This is only useful. It is also not important. See, these all not required. 1.5. Now, next 1.3. JDK 1.3. 2000. No changes at language level. No changes at language level. No changes at language level. JDK 1.4, 2002. One concept assertions. JDK 1.5, 2004. Here many features came. Enhanced for loop, for each loop, covariant return type, var aux, enumerations, assertions, assertions already is there, annotations. Generics, static imports, auto boxing and auto unboxing. These 8 features in 1.5 version released. JDK 1.5, 2004. So 8 features, 1.5 maximum changes came. 1.5. So many changes are there. Many new features came. Is it over? So 8 new features in 1.5. See, Java SE5. This is J2 SE. Here Java SE they call. See, generics, annotations, auto boxing, enumerations, var aux, enhanced for loop, for each loop. That is only static imports. Okay. These all are given. Up to Java SE5. First I'll complete. Later Java SE6 will see. See, Java SE4, J2 SE4. Here. These all not important. Only assert keyword. That is also not important. Okay. Assertions nothing but assert keyword. Okay. Now, in this all. Here, in initial language, 1995 Java first version, initial language. Later 2 features came. Inner classes and serialization. Inner classes completed, serialization completed. Okay. I have to teach strict FP keyword. have to teach assertions. Enhanced for loop already completed. Covariant return type completed. Varrocs have to teach. Enumerations have to teach. Annotations have to teach. Generics also completed. Static imports also completed. Auto boxing, auto unboxing also completed. Okay. Which are not covered, I'll teach. Now, strict FP keyword. Note on. Strict FP keyword. Strict FP keyword. See, note on. It ensures that to get same result on any platform while performing operations on floating point numbers. It ensures that to get same result on any platform while performing operations on floating point numbers. So actually, while performing operations on floating point numbers, on Windows one result, on Linux one result, on Solaris one result, different operating system, different output comes. If you write strict FP, strict to floating point, if you write on Windows also, Linux, Java is platform independent only, but floating point operations are platform dependent. On Windows one result comes, on float, on Solaris one result comes, on Mac OS one result, like that comes. But if you attach strict FP keyword, in all platforms, same output comes. See, for example, say class demo, here public static void main string args. Here if you write float A equal to 10.0 F something, float B equal to 3.0 F, system dot out dot println A by B, I'll write. Okay, file save. I'll compile, I'll run. Java C demo.java, Java demo. You are getting something 3.3333. How many digits coming? 7 digits. Okay, like this. Some operating system, last one, it will become 4. 3.3333, 4 comes. Some operating system directly here after 3 digits only 4 comes. So this output on Windows, this is coming. On Linux, maybe that is last digit 4 comes. On Solaris, maybe 3.4 comes. That we cannot predict. So this output is different operating system, different type comes. But once if you attach strict FP keyword, if you attach, now whatever we are going to get now, that output only, this output only comes in all operating systems. This output only on Linux also, this output only on Solaris also, this output only Mac OS also. On any operating system, same output comes. Once if you attach strict FP keyword. But strict FP keyword, you can apply to classes, you can apply to methods, you can apply to interfaces, but you cannot apply to variable. You cannot apply to constructor. Okay. If you write, error comes. See, next write it. Strict FP keyword is called as modifier and it can be used with classes, interfaces and methods only. Strict FP keyword is called as modifier and it can be used with classes, interfaces and methods only. If the class or interface prefixed with strict FP keyword, then all methods of class or interface are implicitly strict FP. If the class or interface prefixed with strict FP keyword, then all methods of class or interface are implicitly strict FP methods only. So in a one class, 10 methods are there. 10 methods, if you want to make it strict FP, just a before class if you write, it becomes all strict FP. So in all operating system, if you want to get a same result, then we have to use strict FP. Is it over? If the class or interface prefixed with strict FP keyword, then all methods of a class or interface are implicitly strict FP methods only. Suppose in a class 10 methods are there. 10 methods you want strict FP only. Then no need to write 10 times. Before class you prefix strict FP, all become strict FP only. Okay. This difference I cannot show because two operating systems required. Then we can see the result. Okay. This program, if you execute on Linux, Unix, Solaris, different operating system, then only you can see the effect. Remove strict FP, add strict FP, then see the results in different operating system. Then only we can see. Okay. Example, note down. Example. Java 8 features are most important. Java 8 features. Okay. That is programming style is changed totally. Functional programming. That is day after tomorrow you'll see. Today this up to 5 features. Tomorrow 6 and 7. After that 8. Is it over? So this strict FP if you write, if you remove also no effect in one operating system, because to get the same result on multiple platforms, that strict FP we use, but I cannot show the difference with one operating system. One more operating system is there, we can see. Okay. Now, whatever we are getting here, 1 week it will take, 1 week. Say strict FP. If you write strict FP, now whatever we are getting 3.33 something you are getting now, that output only in Windows also, Linux also, Unix also, Solaris also, you'll get a same result. That is strict FP. But suppose if you write strict FP here, it is an error. It is an error. File, save. Compilation. See, class, interface, enum or record expected. So you can apply to class, you can apply to interface, enum, record. Record also new feature. Enum also new feature. These two new features. Okay, here error comes. Record Java 17, 16 features. 14 onwards, first preview, second preview, like that. Finalized in 16 version. That is also you'll see. So here if you write, error comes. You cannot write. Suppose if you write here, it is valid. It is valid. Say file, save. Compilation. See execution. Working no? Suppose if you write with constructor, it's an error. Suppose if you write with constructor, see file, save. Compilation. See error. Modifier strict FP not allowed here. You cannot write. Okay. And even if you write before instance variable also. Suppose strict FP float like x equal to 3.43f. See file, save. Here also error. Compilation. See modified strict FP not allowed here. So you can write variable, classes, interfaces, methods. That's it. Other places error. Okay. This is about strict FP keyword. Next, no changes at language level. Next, assertions. Next node, assertions. An assertion is a condition that must be true during program execution. An assertion is a condition that must be true during program execution. Assertions are used to identify logical errors. An assertion is a condition that must be true during program execution. An assertion is a condition that must be true during program execution. Assertions are used to identify logical errors. Assertions are used to identify logical errors. See, you studied already how many types of errors are there? 3. What are those? Compile time errors, runtime errors, logical errors. Suppose if any compile time error is occurred, that mistake will be shown at compile time. Message also comes. If any runtime error is occurred, exception. Runtime error nothing but exception. That is handled by try-catch blocks. You will get error message. If any logical error occurred, what will be happen? Will it compile or not? Program compiles or not? Compiles. Will it execute or not? Executes. What is the result of front logical error? Wrong output. Program successfully compiled. Program successfully executed. You will get a wrong output. Seeing that wrong output, you will understand some mistake happened in logic. Okay. Seeing that wrong output, you'll understand mistake happened in logic. But what is a mistake? You have to find out. That is your responsibility. Compiler will not show. JVM will not show. Operating system will not show. That is your responsibility. How to check? With assertions, we can check. See. Next, write it. In order to use assertions, assert keyword and java.lang.assertion error class were introduced in JDK 1.4 version. In order to use assertions, assert keyword and java.lang.assertion error were introduced in JDK 1.4 version. An assertion is a condition that must be true during program execution. Assertions are used to identify logical error. See, if any logical error is occurred, program successfully compiled, successfully executed, but output wrong comes. Seeing that wrong output, you'll understand some mistake happened in logic. But where is a mistake? What is a mistake? You have to identify. That is your responsibility. How to identify is with assertions will identify. Okay. See, for example, suppose you'll write like this. You studied scanner class, no? Scanner is equal to new scanner. System.in. Next, suppose system.out.println print. Enter any number between 1 and 10. Suppose my application requires one input number that should be 1 to 10 only. Between 1 and 10 only required. I written like this. You studied integer x equal to s dot next int. Will print system.out.println x. Scanner class in which package? Java.util package. Now see, I'll compile, I'll execute. Here, enter any number between 1 and 10. Suppose I entered 56. Will it print 56 or not? Yes or no? See the program. Will it print 56? Yes. I asked user to enter 1 to 10, but user entered out of range also. It is accepted, printed. It is nothing. Okay. It is just information I passed to user, but user not followed, but printed. It is printed. Okay. Now, suppose we written some logic between 1 and 10 purpose only logic written. If you enter 56, wrong input, definitely wrong output comes, no? This input whether entered or not, you have to display error. So what I'll do here, one assertion condition I'll write. Assert x greater than 0 and x less than or equal to 10. If I write one condition, I written assertion is a condition. As an assertion is a condition that must be true during program execution. Like this one condition I written. Okay. Now I'll compile. File, save. Compilation, execution. If I enter 34, no change because by default assertions are disabled. Note on that point also. By default, assertions are disabled. To enable assertions, we use the following. Java-EA demo or Java-enable assertions demo. So instead of writing complete enable assertions, -EA also you can write short form. -EA. -EA. -enable assertions. Now, if wrong input is there, so I didn't write any logic there. I didn't write any logic. Suppose wrong input is there, definitely wrong output also comes. Logic written 1 to 10 suppose, but input only wrong, definitely wrong output comes. That is you can identify with assertions. How? You observe. File, save. Now, Java-EA demo. If you enter, see, you are getting error. Program terminated. So what we can do, suppose you written some logic. These many lines of code is there, suppose. Like this, many lines of code is there. Okay. Now, you got some wrong output. Program successfully compiled. Program successfully executed, but you got a wrong output. Then what you can do, some assertions you can add. Suppose 2 assertions added. If the program up to here only successfully executed, here stopped, then you can understand logical error in this only. Suppose your program executed up to here, then you can understand logical error is here. Suppose complete executed, then you will understand logical error is here. Suppose you identified here logical error. You can add some other assertion statements. Now, either here or here or here, you can identify. But you can ask one question, instead of assert keyword, if condition also you can write no. If condition also you can write no. Suppose if you write with if conditions, like identification of logical error purpose, you written some if conditions. Okay. After identifying if conditions, you have to remove again. If you don't remove, one more logical error also may occurs. But assertion no need to remove, because by default disabled, no. By default disabled. So no need to remove. You written program. There are some if conditions also present. Identification of logical error, some more if conditions you written. Then which is logic purpose written, which is identification of logical error you written, you cannot identify again. Confusion comes. That's what assert. But actually, are you writing any logic? No. Maximum you are depending on Java library only. If you write a program with your own logic, logical error may occurs. But sorting also library, searching also library, hashing also library, finding maximum of 2 numbers also library is there. Finding maximum of 2 number, addition of 2 numbers also library is there. Then we are not going to write any logic. If you write a logic, logical error may occurs. Okay. So that's what assertions are very rare situation we use. Okay. It is not much important. Okay, identification purpose I written. Okay, that is if else statement, that is only explained. If you write instead of assert if else statement, if you write, again you have to remove. And also logic also may contains if else. Logical error identification also if you write if else. That if else, this if else, you'll get a confusion also. Okay, that's what assertions. It is not much important. Write example. Example. Is it over? See this program, if you compile, if you run a compilation normal while executing -EA, if you write, then only you can see the difference. Okay, so how to execute I given. So like this, either like this or like this. Okay, now if you enter between 1 and 10, then only it will be accepted. Okay, if you enter between 1 and 10 only, it will print. See, compilation, execution, like this if you write, no difference. -EA, see, printed, -EA, error. Okay, like this. Is it over? Next concept, 1.4 completed. 1.5, 1.5. By default disabled. To enable your write. Now, 1.5, enhanced for loop. You already studied. Covariant return type. Study now? Varox next. Varox. It means variable arguments. It means variable arguments. It means variable arguments. I'll explain. Suppose void display integer A, integer B, integer C. Now demo D equal to new demo. D dot display. If I write two arguments, is it valid? If I pass two argument, is it valid? No, it's an error. If I pass four arguments, is it valid? Valid? No. So it takes three arguments. Less number of arguments also error. More number of arguments also error. Okay. Save, file, save. If I run, you'll get error. See, method display in class demo cannot be applied to given type. Required 3 integers, found 4 integers. Actual and formal argument list differ in length. You study know what is actual, what is formal? Now, these are actual or formal? Actual. Here, formal. Length is different. Here 4 arguments, here 3 arguments. Okay. Actual and formal arguments length is different. You will get an error. If you pass less also error. Same error. See. File. Save. Compilation. See. Actual and formal argument list different length. So here 3 required, 2 we passed. Okay. You'll get a same. Now with this feature allows to pass 0 to any number of arguments to a method. This feature allows to pass 0 to any number of arguments to a method. This feature allows to pass 0 to any number of arguments to a method. If it don't pass, also valid. 1 also valid, 2 also valid, 3 also valid, 4 also valid, any number of. See here, but you need to write like this. 3 dots, this syntax. Now dot, 3 dots, like a dash, etc. We'll write no, dot, 3 dots. Okay, 3 dots if you write. Now if you don't pass arguments, valid. D dot display. Say 1 argument, valid. D dot display. 2 arguments, valid. D dot display. 3 arguments, valid. Any number of. There is no limit. See, file, save. Compilation, execution. Valid, no? But how to print? You can go for enhanced for loop. For int b colon a, you can print system.out.println b. Now here no arguments, no output. Here 1 argument, 1 printed. Here 2 argument, 2 printed. 3 argument, 3 printed. See, first 0, no argument, no output. Next to 1 I passed. Next to 2 I passed. Next to 3 I passed. All accepted, all displayed. Okay. Other data type not allowed. Error comes. Now, but while writing this one, it should be last. Suppose if you write like this, void display integer a, integer b, integer like this c, it is valid. Okay. Suppose void display, if you write like this, it is not valid. It is error. Because if you write like this, suppose if you pass 3 arguments, 3 will receive here only, no? If you pass 5 arguments, 5 will be received here only. Then BC it will not accept. Now, if you write like this, minimum how many you have to pass? 2. Maximum n number of. This is compulsory you have to pass. This is compulsory you have to pass. Here optional. If you write like this, error. So varrox must be last argument. Okay. Now you write this one. Varrox must be last argument. Otherwise error comes. Otherwise compile time error occurs. This is called varrox. So it should be last. Varrox must be last argument, otherwise compile time error occurs. So it is valid, it is not valid. If you want to write varrox, it should be C only. It is B also error, A also error. So last to right to left only you can write. Okay. Last only you have to write. Is it over? Example note down. These two also write it. Written? Write this one. Example. Is it over? So this is called Varox, but it should be 3 digits only. It should be 3 digits only. So any number of parameters we can pass. There is no limit. There is no limit. In real time also, this is only concept. Okay. See, if you don't know number of elements, how many you have to pass? In that situation, you can use this. If you know the number of elements, you can pass properly. Otherwise, this concept. Now, even here also, it is array, no? But array different, this is different. Array means array only you have to pass. But like this, you cannot pass. So it is also, main method also supports. Like this. Like a command line arguments, n number of you can pass. That is also Varox also allowed. Okay, it is also will compile. See, file, save. Command line arguments also valid. Here also Varox you can write. This is Varox. Next concept we'll see. Say enumerations, enum keyword. Next write it. Enumerations. This feature allows us to create a new data type. This feature allows us to create a new data type. Scanf, printf, libraries, no need to learn. This feature allows us to create a new data type. In order to use this feature, enum keyword introduced in JDK 1.5 version. In order to use this feature, enum keyword introduced in JDK 1.5 version. Say enum keyword. This feature allows us to create a new data type. In order to use this feature, enum keyword introduced in JDK 1.5. Now, why we need to create new data type? I'll explain. Suppose, for example, if you want to accept minus 128 to plus 127, which data type we use? Byte. Okay. Suppose if you want to allow only minus 128 to plus 127, byte data type is there. Suppose if you want to enter Monday to Saturday, Monday to Sunday, which data type we use? Which data type? String data type we use. But suppose minus 128 to plus 127 only should allow. Then byte data type. Suppose by mistake, if I write 130, we'll get an error. So here, you observe byte b equal to 130. If I write system.out.println B. It's an error. File, save. Compilation. See, incompatible types. We are getting error 130 out of range. Suppose if we enter 120, it is valid. File, save. See, successfully compiled, successfully executed. Okay. Now, but if you want to accept Monday to Sunday, string data type we use. Now, string yes equal to Monday. If I use yes, you'll get a Monday. Suppose if I enter ABC, accepted or not? Accepted. So actually, for storing Monday to Sunday, there is no special data type. We are using string. But if we enter ABC also valid, see, it is error. It is valid. Now my intention is I want to maintain only Monday to Sunday. By mistake, if a user enters other than Monday to Sunday, it should display error. That is my intention. For this, there is no specific data type. In this situation, you create your own data type, which should allow only Monday to Sunday. If you enter any other, which should display error. How to create? See. What you can do is enum keyword. Enum. Data type name. Day. What you want to allow. You can write. Like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Now, day is a data type. Day is a data type. These all day literals, not string literal. String literal means double quotes compulsory, no? Now, I created new category of literals, which allows only Monday to Sunday. See, integer x equal to 10. What is int? Data type. What is x? What is 10? Literal. Like that, day, d equal to Tuesday. Now, what is day? Data type. What is d? What is Tuesday? Literal. So, myself, I created one new data type. The data type name is day. Okay. Here, day is a data type like a int. D like a variable x. Tuesday like a 10 literal. But if you write like this, error comes. File, save. See, cannot find symbol. Tuesday cannot find because these all implicitly static. Compulsory you write day dot Tuesday, then only valid. So now if you print system.out.println D, you'll get a Tuesday. See? Okay. Now, next write it. Example. In the above example, day is a data type. In the above example, day is a data type. So now day is a data type. Is it over? So these are called enumeration literals. It is day is a data type. These are literals. All enumeration literals are implicitly static. That is the reason day dot Tuesday. That is your right. Okay. Next, write it. Java compiler generates dot class file for enumerations also. The Java compiler generate dot class file for enumerations also. That means day dot class file created. Day dot class. Is it over? Java compiler generates dot class file for enumerations also. Here enumerations over, next annotations. Annotations are meta tags that are used to pass some additional information to compiler about class, interface, method, dash dash, etc. Annotations are meta tags that are used to pass some additional information to compiler about class, interface, method, dash dash, etc. All annotations begins with its symbol. Useful annotation, only one annotation is there in core Java. Two annotations are there. One is Java 8 feature. What is that? I'll explain. Annotations are meta tags that are used to pass some additional information to compiler about class, interface, method, dash dash, etc. All annotations begins with its symbol. Is it over? So its symbol, if appears, then you can understand there is an annotation. See, for example, class test, void show, system.out.println test class. Okay, otherwise some core Java. Next, class demo extends test, void show. What is this concept? What is this? Inheritance. Next, overriding. Suppose public static void main string args. Okay, string args. Here demo D equal to new demo. D dot show. What is the output comes? What is the output? Advanced Java. File save. Okay. Compilation execution. You are getting advanced Java. Suppose integer x. Now, what is the output? Core Java. File save. Compilation execution. Okay. Now, what is this now? Overloading or overriding? Overloading. If I remove this, overriding. Okay. Actually, my intention is overriding, but by mistake I written like this. Program successfully compiled, successfully executed. We got that output because it is overloading. So overriding means parameters must be same, no? So one annotation, if you attach, this is called annotation. If you attach, what system will do, whether it is overridden or not, it will check. If it is not overridden, error comes. File save. So what I'm informing to compiler, I'm overriding. So what system showing? Method does not override or implement method from super type. So with this line, I'm informing to compiler, it is an overriding method. I inform it to compiler. Then what compiler will do? All overriding rules, it will check. If it is followed, successfully compiled. Not followed, error comes. Overriding rules, many are there, no? Return type must be same, except covariant return type. Parameters must be same. Method name must be same. And final method, we cannot override. Static method, we cannot override. Private method, we cannot override. Access modifier must be less or more, less or same. All rules compiler is going to check. Just if you attach this one. So what I am informing to compiler, it is an overriding method. I am informing. Then what compiler will do? Superclass, subclass, both the places it will check whether it is overridden or not according to rules. If not overridden, error comes. So programmer no need to check the rules. Compiler will check. That is additional information we are passing. That is override annotation. Write this example. Example, I'll give description. In the above example, at override annotation informs compiler show method is an overriding method. Then compiler will check. If it is not overriding, error comes. If it is overriding, compiles. We are informing to compiler it's an overriding method. In the above example, at override annotation informs compiler show method is an overriding method. So Java 1.5, JDK 1.5, 8 features are there. Remaining features I taught already. Is it over? See. Next, generics. Generics already over. Static imports already over. Auto-boxing, auto-unboxing completed. Okay. Up to Java 1.5 completed. Tomorrow 6, 7. 6, 7, 8 also will start. Okay. Java 8 features most important. Okay. One more annotation is there. I'll teach in the 8 at functional interface. This is next Java 8 feature. Later I'll explain. No need to write. Later I'll explain. Now, so up to Java 1.5 completed. Java 1.5. 6, 7, 8 also will start tomorrow. Okay. Tomorrow we'll see continuation. Any doubt? I'll start tomorrow. 6, 7, 8. I didn't get you. Edit plus you are asking. Okay. In the above example, at override annotation informs compiler show is an overriding method. Then compiler will check. Compiler will check it is overriding or not. If it is overriding, compiles. Not overriding, error comes. Okay. We'll see continuation tomorrow. Advanced Java batch not decided, but core Java batch decided. Advanced Java batch not yet decided. But core Java batch decided morning 9 o'clock on 20th May. We'll see continuation tomorrow.